Hey, I'm Peter, and together with Matt, we're going to take a look how to simplify streaming pipelines for Apache Iceberg with Snowflake. First, we'll take a look at what dynamic tables are. Then we'll take a closer look at dynamic Iceberg tables. And finally, Matt is going to show them in action. So what are dynamic tables? Dynamic tables are a new type of table that automatically and continuously materialize a query's result. In other words, they're declarative data pipelines. A typical data engineering setup would ingest data into landing tables via Snowpipe used for batch ingestion or Snowpipe streaming used for row-level ingestion. Note that both internal and external connectors rely on these ingestion methods. Dynamic tables then transform the data to make it suitable for consumption by native applications, AI models, BI tools, and other serving layers. So what are the challenges of building a data pipeline and how can you benefit from using dynamic tables? Data pipelines are complex. It's not trivial to manage dependencies, scheduling, and orchestration while you also need to account for multiple points of failure. They're inefficient since they require consistent effort to maintain and improve. Optimizations are manual, complex, and usually localized to a specific problem or pipeline. Furthermore, managing pipelines can often be difficult because brittle pipelines are unable to react to changes upstream. So fixing such issues often requires coordination with multiple teams. On the other hand, dynamic tables are pipelines with native support for streaming and continuous batch processing. So transformations are easy to express given the declarative semantics of dynamic tables, and no orchestration is required even for complex logic. They're cost-effective, they support incremental processing and provide refresh mode recommendations based on automatic query analysis. Furthermore, performance improvements are transparent, and in general, dynamic tables are low overhead. Dynamic tables also cloud native, so you benefit from strong security, governance, and scalability. So what are the key features of dynamic tables? Dynamic tables are declarative data pipelines, so they're easily expressible. You don't need to worry about scheduling or orchestration because dynamic tables do it for themselves. Dynamic tables also support low latency data freshness, controlled by the target lag. Currently, data freshness as low as 1 minute is supported, while single-digit seconds is in the works and will be supported in the near future. You can express transformations using SQL syntax, and Python and REST APIs are coming soon. Dynamic tables provide automatic query analysis with refresh mode recommendations and a detailed performance guide for tinkerers. Dynamic tables also provide pipeline level controls. So you can suspend your pipelines, trigger on-demand refreshes for a single DT or for your full DAG, and you can manipulate additional properties. They also excel at observability. So you can visualize your DAG and you can check the status of your pipeline. You can monitor the refresh history and more. What are dynamic Iceberg tables? Dynamic tables can now read from Snowflake managed Iceberg tables. You can build hybrid pipelines reading from regular tables, views, dynamic tables, and dynamic Iceberg tables. Dynamic Iceberg tables bring the best of both worlds. They operate like dynamic tables while they materialize data in Apache Iceberg format. Furthermore, they can sync with the Polaris catalog just like regular Snowflake managed Iceberg tables. So why Apache Iceberg? Because our vision for your data lakehouse is built on the interoperable and vendor-neutral format Iceberg. Having the Iceberg table registered to the Apache Polaris catalog provides a unified cross-engine governance, and this enables you a full spectrum of workloads with the flexibility to mix and match different tools. Where do dynamic Iceberg tables fit into your data pipelines? You can build Iceberg-only or mixed declarative data pipelines. The result of your transformations are seamlessly materialized in Iceberg format and are accessible through the Polaris catalog in your data lake. Here's an example for how to build your lakehouse on Iceberg and Polaris, which opens the door for interoperability between Snowflake and other tools. This architecture provides the unique benefit that with Polaris, you get access control across Snowflake and any other tool you choose to integrate with. In terms of data transformations, Snowflake provides tools for batching and streaming ingestion, as well as to build declarative and imperative data pipelines, all compatible with Iceberg. Now it's time for the demo. I'm going to hand it over to Matt. He'll show us how to build data pipelines that consume from Iceberg and non-Iceberg sources and use dynamic Iceberg tables. He'll also show us how to sync the pipeline with the Polaris catalog. Over to you, Matt.
Thanks, Peter. Hi, everyone. I'm Matt. I am an engineer on the dynamic tables team. I'll be walking you through the demo portion of this. We're starting with the graph history or the graph view of the pipeline that we'll be building today. The scenario for the pipeline is we will be tracking shipments and order history and progress of shipments of pharmaceutical medication as they're en route to their pharmacy. The pipeline will be made up of a couple different types of tables. We have Iceberg tables, dynamic Iceberg tables, and FDN tables, or just default Snowflake tables. So you can see from the graph here, we have a shipping log, a location table, a customers table, an orders table. We have a shipping history, which is a dynamic Iceberg table, and we have a shipping state, which is also a dynamic Iceberg table. In this scenario, every time something happens to a shipment, it is going to append a new entry in the shipping log. So for example, when an item is placed for order, there will be an entry in the shipping log. When it's processed and put on a truck, there will be an entry in the shipping log. When it's out for delivery and when it's finally delivered to the customer, those will all be new entries in the shipping log. Each location in this route to its final destination is a separate location in the graph. So it could be a warehouse, a truck, the pharmacy that it ultimately gets delivered to. We have a shipping history, which is a dynamic table where we will be building an SCD type 2 pipeline. So every time a new log entry is appended, it will terminate the old entry, use the timestamp as an updated entry in the shipping history with a new log. Then we have our customers table and our orders table. And then we have the shipping state, which is a dynamic Iceberg table, which can be queried to find out the current state of a shipment, whether it's already been completed and delivered, or whether it's been processed or on a truck. So here's the demo code. We're going to start off by just creating, a demo DB and a demo schema. This is the external volume that we're going to use for all of the Iceberg tables in the demo. So we can go ahead and create that. This external volume has been configured to write to this S3 account. Specifically to this dynamic Iceberg table demo. Different Iceberg tables in the demonstration will have different base locations. They'll all be written in this bucket, and we will come back to this later on. We're also going to show these dynamic Iceberg tables syncing to Polaris, which is functionality that we're releasing shortly. All the Iceberg tables that we are created will use this catalog integration. They will sync with the Polaris catalog, and then we will show later how to query these tables from an Apache Spark connection. So all of the credentials, permissions, AWS roles, and IAM properties have already been configured for this demo, so we won't be going over that. So let's go ahead and create some of the tables in our pipeline. Here is the shipping log. And we're going to insert some data into the shipping log. So we can see here that the shipping log has a location ID, an order ID, an updated on timestamp, and an update reason. So in this case, we can see, we have order ID 1 has gone through location 1, 2, 3, 4, 5. These are the timestamps of the stage change. And the update reasons, we had an order that was processed, then it was put on the truck, moved to a distribution center, was out for delivery, and then it was finally delivered to customers. So this is the raw data that we're going to be using in our first dynamic table. We're going to create our location log, which has a couple of locations. We're going to have a virtual location, which kind of signifies that it was placed for order on the website or however people are ordering this medicine. We have a truck, we have a warehouse, we have a van, and then we have pharmacy XY, just to signify the customer in this case. It was delivered to some pharmacy. Okay, we can see that this table's been populated correctly. We have our customers table. Right now we have two customers we're going to use in the demo. We have Downtown Pharmacy and Village Pharmacy. We can see that was populated okay. Then we're going to create our orders table. Right now, an order is just going to be associated with one customer. It's going to have an order ID, and then it's going to have some quantity of medicine that they've ordered. So here, we insert some data. We see that customer ID 1 made order 1. They ordered 100 units. Customer 2, order 2, 150 units. So here's our first dynamic iceberg table. It's using a warehouse to run the queries on. The target leg is downstream. And what this means is that this dynamic table will not refresh on its own or at any cadence. It will wait for somebody to request data from it, at which case it'll refresh. It is an iceberg table, so it's going to use the external volume that we used earlier. It's going to write all of its data to the DT shipping history base location. This will be written to the dynamic table bucket that we saw earlier. And it's also set up to sync to the Polaris catalog, the Polaris catalog integration. So what this is doing is it's using a window function to create an SCD type 2 table. It's going to process the shipping log and the location. And for every state change, it's going to append a new entry into the table. So we can go ahead and we can create this. And we can see here from our records that we have order ID, we have the location ID, we have the reason for the update in this table, and then we have a start and an end time. So if we walk through order ID 1, it was placed at location ID 1, which was our virtual online store. It was updated because the order was processed on September 16th at 13:47. It stopped being processed at 14:47, at which point it was put onto the truck. So you can see that the end time of the previous record becomes the start time of the next row. After it was put on the truck, it was moved off the truck at 15:47, which is when it arrived at the distribution center. It departed the distribution center at 16:47, which is when it was marked for out for delivery. And then it was delivered at 16:55, which is the start time of the delivered to customer reason. And this has no end time because it's finished its journey. You can see a similar pattern for order number 2, which is still out for delivery on the truck. So at this point, I'm going to force push a notification to the Polaris catalog. If we come back to the Polaris catalog, there's a couple things we can explore. So one is that we've created this dynamic iceberg table demo catalog. We've created 2 roles. These have already been configured. One is for the Apache Spark role that we'll use later in the demo to query data from Polaris. The second role is this dynamic iceberg table demo role. This is the role that grants permissions for Snowflake tables or tables created in Snowflake to be synced to Polaris. We've granted some permissions to these roles so that they can operate on the tables correctly. And if we refresh our catalog, we can now see that we have the demo DB, the demo schema, and we have our DT shipping history and the DT log, which were the iceberg tables that we created earlier. We can also see if we go back to S3, we have our dynamic iceberg table demo. This is the data for each of the iceberg tables that we created. So the DT shipping history dynamic table is writing its data to this bucket. And the shipping log iceberg table that we created is writing its data and its metadata into the shipping log base location. So if we head back to the demo now, we can create our second dynamic iceberg table. This is the shipping state. And this is the current view of the order that you can query to figure out where an order is, whether it's out for delivery, whether it's already been delivered, as well as the location and the last timestamp. So here we've created this dynamic iceberg table. And we can see both of our orders. One was for Downtown Pharmacy. They ordered 100 units. This was the time the order was delivered to Pharmacy XY. And you can see that the update reason is delivered to customer. And then we have our second order to Village Pharmacy. They ordered 150 units. It's on the truck, so it's not yet been delivered. And the last timestamp that we have was September 17th at 4:47. So I'm going to force push another notification to Polaris just so that we can come back here. We can refresh. We now see that the dynamic iceberg table has been synced to Polaris. One of the nice things about using dynamic tables in these pipelines is that it's very easy to go back, make changes to the base tables, and have them reflected in the dynamic tables. You don't need to write any custom logic to determine which records have changed, what ones need to be inserted or deleted. In our case, let's imagine that there is a timestamp which was incorrectly logged to the shipping log. Let's say that the timestamp for order 2 and location 2 is currently September 17th at 4:47, and this needs to be updated to September 18th at 11:47. So we can make this update. We can see that this is now updated in the shipping log. If we refresh the shipping history dynamic table, you can see that there are only 2 inserted rows and 2 deleted rows. We didn't need to reinitialize the table or repopulate the table with data. Only the records which were involved in this update were changed in the dynamic table. So we can also see that in our dynamic table, the start time for the order 2, location 2 was updated. Okay, so now let's go ahead and pretend that another customer made an order. In this case, we're going to create a new customer called City Pharmacy, insert that into the customers table. They are going to have a new order with the ID order 3. They ordered 250 units. We are going to insert some values into the shipping log. So their order was processed, then was placed on the truck, and then it arrived at the distribution center. If we refresh the DT shipping state dynamic table, we can see that this was an incremental update. There were only 2 rows inserted and 1 deleted. We can also see that the new customer, City Pharmacy, had ordered 250 units. It's on the distribution center at the Seattle warehouse, and this occurred Wednesday, September 18th at 1900. We can go ahead, complete the order for them. So their delivery went out for delivery. It was ultimately delivered to the customer. And again, if we alter the dynamic table shipping state, we can see it was an incremental update. And we can now see that City Pharmacy's order was delivered to the customer. So if we go back to our Polaris catalog, we can see that we have all of the iceberg tables that we created as part of our pipeline. If we come over to the terminal, there is a Spark client which has been configured to interact with this Polaris catalog. We can run the show namespaces. So we see that the demo DB namespace is active. We can use this demo DB namespace. And we can also query the dynamic iceberg tables that have been synced to the catalog. So in this case, we can select everything from the DT shipping state. You can see here we have the customers, Downtown Pharmacy, Village Pharmacy, City Pharmacy. We have their orders. We also see that they've been delivered to the customers. And these updates are all the most recent updates. So after we added the City Pharmacy, updated some of the entries to their shipping log, these changes have been synced to Polaris. Apache Spark is able to connect to Polaris as a reader and query these tables. We can do the same thing for the shipping history. Let me just change this real quick. All right, so this is the shipping history dynamic iceberg table that we've created, which shows the entire history of an order throughout its lifetime. This was synced to Polaris. Our Apache Spark client can go ahead and read all of the data from these tables in real time. So while we can express SCD type 2 using lower level primitives like streams and tasks, the code becomes much more complex. So the following code snippet uses streams and tasks to implement incremental updates similar to what our dynamic tables provide out of the box. The high level building blocks are a stream to capture the changes over time. In this case, the stream on the shipping log. We would need a task that implements incremental update logic. For our use case, a window function that operates on a group of related rows known as partitions. In our example, rows with the same order ID should be reprocessed if any of them are inserted, deleted, or updated within the partition. For a specific change interval, we would need to identify all the changed partitions for our window function. We would need to delete all the entries for these changed partitions and then recompute the rows for the changed partitions as well. So in a small pipeline, this can be manageable. But as your incremental update logic becomes much more complex, involves joins or multiple tables, you can slowly spiral into writing a very convoluted and complex stream and task pipeline. This is a behavior that you get for free with dynamic tables. Thanks for watching. This was the end of our demo. We saw how to create dynamic iceberg tables. We saw how to sync these dynamic iceberg tables to Polaris. We saw the advantages of using dynamic tables in a pipeline, the incremental updates and the ease of use. And we also saw how Polaris catalogs and tables can be queried from third-party engines like Apache Spark. Thanks. Back to you, Peter.
Thanks, Matt. In this presentation, you saw how easy it is to create declarative data pipelines on top of an Apache Iceberg Open Lakehouse. If you want to learn more about dynamic tables or dynamic iceberg tables, check out our documentation.